There are two purposes for the grounding and shielding of electric circuits. The first purpose is safety. The second purpose is to reduce electromagnetic interference. The ground of a circuit is the part of the circuit that is defined as 0 volts. However, it is only meaningful to talk about the difference in voltage between 2 points. Therefore, which point on the circuit we decide to define as 0 is arbitrary. We can pick any location and call it the circuit ground. The voltages of all other points on this circuit will be defined by how much their voltage is different from the point we decided to call circuit ground. However, the word ground also has another meaning, and this is the physical ground of the earth that we are standing on, which we will call earth ground. The voltage of the earth ground can be significantly different from the voltage of the circuit ground. This is especially true if the circuit is powered through a transformer. A transformer only guarantees how the voltage difference across the primary coil will compare to the voltage difference across the secondary coil. But if the voltage at both ends of the secondary coil both increase or decrease by the same amount, then the voltage drop across the secondary coil has not changed. Therefore, the total voltage at the secondary coil can be any value. This can create a very dangerous situation if the voltage is extremely high. We can fix this problem by connecting the circuit ground to the earth ground, so that both the circuit ground and the earth ground will be at the same voltage. The need for a connection to earth ground is the reason that power outlets have 3 holes. 2 of the holes are for the 2 ends of a transformer coil, and the 3rd hole is for earth ground. We can make a circuit safer by surrounding the entire circuit in a metal enclosure connected to the circuit ground, and then connecting the metal enclosure to earth ground. This way, it is safe to touch from any direction, due to the fact that the entire metal enclosure is at the same voltage as the earth ground. But there can still be a problem due to the fact that the earth and the metal wires in the circuit are not perfect conductors. Both the earth and the metal wires have some resistance to them, and therefore not all points on earth ground or on circuit ground are necessarily at exactly the same voltage. This can cause considerable problems for the proper operation of the circuit and for safety. Some people are tempted to try to fix these problems by adding more connections at different points between circuit ground and earth ground, so as to reduce the resistance. However, this can cause even more problems because this creates what we call ground loops. Loops act like antennas, which can both pick up and transmit electromagnetic waves. A changing magnetic field through a loop causes current to flow around the loop. The larger the area inside the loop, the greater this effect, and the more it interferes with the proper operation of the circuit. In the case of sensitive circuits, this type of current flowing through ground loops will prevent the equipment from working altogether. When we connect the circuit ground to the earth ground, or when we connect the circuit grounds of different circuits together, we can avoid creating ground loops by connecting all the grounds together at just a single point. Even if we eliminate all the ground loops, a circuit still inherently has to have loops due to the fact that current eventually returns to where it came from. But we can reduce the areas of these loops by keeping the wires for the current and for the return current close together. This reduces the amount by which incoming electromagnetic waves will interfere with proper operation of the circuit. And it reduces the amount by which this circuit will emit electromagnetic waves which may interfere with other equipment. These two types of electromagnetic interference can also be significantly reduced by placing the circuits in a metal enclosure which is connected to both the circuit ground and to earth ground. This is the exact same procedure we used to help improve safety. Much more information about electric circuits is available in the other videos on this channel. Please subscribe for notifications when new videos are ready.